Hi, my name is Dr. Ahmath. In this video lecture, we are going to solve the problems of exam number 2 in Calculus 2. Well, there are 15 problems, some of them on the series, some of them in the power series, some of them in vector functions, vectors, and vector equations. Let's start the first one with evaluating the sum. So I would like to write down a couple of its first term in order to figure out what kind of series I've got. So I'm just going to start from n 0 is equal to the 0 and write down a couple of its first terms. When n is equal to the 0, it's going to be 2 to the power of 1 divided to the 3 to the power of 0. Well, that's going to be simply 2. When n is equal to the 1, it's going to be 2 to the power of 2 divided to the 3. It's going to be 4 over 3. When n is equal to the 2, it's going to be 2 to the power of 3 divided to the 3 to the power of 2. Well, that's going to be 8 divided to the 9, and so on. So I can see here that it's geometric series, where the first term, actually, the b1, is equal to the 2, and a common quotient is equal to the 2 over 3, right? So I can just get the second term by just multiplying the first one to the 2 over 3. I can get the third term by just multiplying the second term to the 2 over 3. So there is a formula to evaluate the sum of a geometric series, the Sn, so infinite geometric series, Sn when the limit of n goes to the infinity is equal to b1 divided to the 1 minus q. So I'm just going to plug in everything into this formula and evaluate the sum. It's going to be 2 divided to the 1 minus 2 over 3. On the denominator, I've got 1 over 3, which goes to the 3 to the numerator. It's going to be 2 times the 3. Well, that's going to be equal to the 6. Well, the sum of this infinite series is equal to the 6. Well, let's solve the second problem. So in the second problem, we need to evaluate the length of this 5-dimensional vector. So the length of any vector is denoted as the norm of the vector is equal to the square root of the sum of the square of the components of the vector. So essentially, I need to get each component of the vector, square this, 4 in the square minus 3 in the square, 3 in the square, 1 in the square, then sum them, and then take the square root of the sum. Well, let's evaluate this. It's going to be 1 plus 16 plus 9 plus 9 plus 1. It's going to be 20 plus 16, which is 36, right? Square root of 36, which is equal to the 6. Well, the norm of the vector v here is equal to the 6. And the next problem, we need to find the sum of the components of the u minus v. So first of all, I'm just going to find the new vector u minus v. It's going to be a 1, 4, 2, minus 3, 4, and 1. Well, we just need to subtract the components of these two vectors component-wise. So it's going to be 1 minus 3, it's going to be 4. 4 minus 4, it's going to be 0. 2 minus 1 is going to be 1. Well, the sum of its components, it's going to be 4 plus 0 plus 1. It's going to be 5. Question number 4, we need to find such a value for the case of the vectors are parallel. So first of all, I need to put the condition when the two vectors are parallel. So the two vectors are parallel if you can get one of the vectors v by just multiplying the u to some constant k, or to some constant c, let's say, in this case. So to some constant c. So I'm just going to write this down. 1k times to some constant should be equal to the 3 and 27. Well, which number you have to multiply the 1 in order to get the 3? So obviously c should be equal to the 3, right? So it should be 3 times the 1k is equal to the 3 and 27. Well, this constant here is equal to the 3. And to which number you have to multiply the 3 in order to get the 27? Well, that's again obvious, it's going to be 9. So your vector should be 1 and 9, so that you can multiply this 1 and 9 to the constant 3 and get the second vector 3 and 27. Well, the value for the k should be equal to the 9. The next question is we have to find the value for the case so the two vectors are orthogonal. Well, the two vectors are orthogonal if and only if their dot product or the scalar product is equal to 0. Well, I'm just going to multiply these two vectors as a scalar product, as a dot product, and equalize this to the 0 and find a k. When you multiply the two vectors as a dot product, you have to multiply their components correspondingly. So it's going to be a 1 times this a 1 plus k times this a 1 and equalizes to the 0, where then k is going to be equal to the minus 1. Well, so for the value of the k to be equal to the minus 1, the dot product of the two vectors is equal to the 0. Consequently, they become orthogonal. In the question number 6, we have to find the angle between the two planes. So instead of finding the angle between the planes, we're going to find the angle between the two normal vectors to the planes. So usually the planes are given with the general equation in the form of ax plus by plus cz is equal to the d. And if you would like to figure out the components of the normal vector to this plane, so essentially the vector which is orthogonal to this plane, you can get this from the general equation of the plane it appears. You can just simply get this as a, b, and c, the coefficients before x, y, and z. Well, instead of finding the angle between the two planes, we're simply going to find the angle between the two normal vectors. Well, that's going to be the angle between the two planes. The normal vector for the first plane, for this plane, n1, is going to be 0, 3, and 0 because the coefficient before the x is 0, coefficient before the y is 3, the coefficient before the z is equal to 0. And n2, the normal vector for the second plane, is going to be 2, 2, and 2. Well, I'm going to find now the angle between these two vectors. The angle between the two vectors, cosine of theta, is going to be equal to the n1 dot n2 divided to the norm of the n1, the norm of the n2. Well, let's multiply 0, 3, and 0. 2 is 2, 2, and 2. And divide it to the norm of the 0, 3, 0, which is going to be equal to the square root of 0 in the square plus 3 in the square plus 0 in the square times to the norm of the second vector, which is 2 in the square plus 2 in the square plus 2 in the square. Well, when you multiply these two vectors, this one to this one as a dot product, it's going to be 0 times this is 2 plus 3 times this is 2, sorry, plus 0 times this is 3. To the 2, sorry, to the 2. On the denominator, I've got 3 times to the 2 times to the square root of 3, right? Well, on the numerator, it's going to be 6. On the denominator, it's going to be 6 times to the square root of 3. Well, that's going to be 1 divided to the square root of 3. And the angle between these two vectors and consequently between these two planes is going to be the arc cosine of 1 divided to the square root of 3. You can use a calculator in order to find this. Well, that's going to be roughly 54.7 degrees. Well, that's how we are going to find the angles between the two planes. The question number 7, we have to find the dot product between the two vectors, which is going to be super easy with respect to the previous problem. So the u dot v is going to be 1, 3 minus 1 times the 2, 2, 2. Then we are going to multiply the components correspondingly. It's going to be 1 times the 2 plus 3 times the 2 plus minus 1 times the 2. Well, that's going to be equal to the 6 simply. The next problem, we have to find the fourth term of the Taylor series. So the Taylor series is equal to this one, where there should be the summation, obviously, where n goes from 0 to the infinity. So when n is equal to the 0, it's going to be the first term, n is equal to the 1, it's going to be second term, n is equal to the 3, it's the third term, n is equal to 2 is equal to the third term, and as n is equal to the 3, it's going to be the fourth term of the Taylor series. We just need to find this. So the fourth term of the Taylor series is going to be the third derivative of this function at the point a divided to the 3 factorials, right, times to the x minus a n the cube. Okay, so let's do this. So the first derivative of the function is going to be equal to the e to the power of minus 2x times to the minus 2. The second derivative of this function is going to be minus 2 e e to the power of minus 2x times the minus 2 again, according to the chain rule. Well, that's going to be 4 times e to the power of minus 2x. So the third derivative is going to be equal to, so minus 2 comes down, it's going to be 4 e to the power of minus 2x times the minus 2, and that's going to be minus 8 e to the power of minus 2x. So we have to validate this term when a is equal to the 0, right? So it's going to be so minus 8 e to the power of minus 2 times the 0, right? Because x should be equal to the 0. We are going to substitute a here to be equal to the 0, divided to the 3 factorials times the x minus 0 and the cube. Well, that's going to be minus 8 divided to the 6x cubed, and the coefficient before the x cube is going to be minus 8 divided to the 6, which is minus 1.33. Well, that's going to be the fourth term of the Taylor series, or the coefficient before the first term of the Taylor series. Question number 9. We have to find a curvature, and we need to use the following formula. So it's obvious it should be the t inside the brackets. Well, first of all, I'm just going to find the first derivative, the second derivative, and multiply them as a cross product. So the first derivative of the t is going to be equal to the 2t, 0 and 1. The second derivative is going to be equal to 2, 0 and 0. Well, I'm just going to multiply these two vectors as a cross product. So they are prime of t times is r2 prime of t. If you remember, we have to create a matrix where the first row is going to be I, j, k. The second row is going to be components of the r prime of t. It's going to be 2t, 0 and 1. And the third row is going to be the components of the r2 prime of t. It's going to be 0, 0, 2, 0, 0. Well, then the determinant is going to be I times to the 0. So minus j times 2. So if we just cut this out, it's going to be minus 2, right? So 2t times 0 minus 2 times 1. So plus k times 2 again to the 0. Well, that's going to be simply 2j. That's going to be our vector, and obviously the norm of this vector is equal to the 2, right? So our vector is going to be, can be written as a 0, 2, 0. J means the second component of this vector. So the norm, so the numerator of the curvature is equal to the 2 because this is the length of this vector. So let me show you how to find the length of this vector. Our prime of t, cross product r2 prime of t. That's going to be a square root of 0 in a square plus 2 in a square plus 0 in a square. Well, that's going to be equal to the square root of 4, or simply 2. On the denominator, we have to evaluate our prime of t at the 0, at the t is equal to the square root of 2, right? Or simply, let's find its norm. The norm of this vector, it's going to be equal to the 2t in the square. It's going to be 2t in the square, which is 4t. Oh, let me just substitute this there. So it's the norm cube, let's say. It's the norm of the 2 times the square root of 2, because t should be equal to the square root of 2, right? 0 and 1, the norm of this vector. Well, the norm of this vector is going to be square root of 2 times the square root of 2. It's going to be 4 times the 2, which is 8, right? 8 plus 0 plus 1. And we still have to get its cube, right? Because there was a cube here. So square root of 9 is 3. 3 in a cube, it's 27. And then I'm just going to put this there. So the curvature, which is denoted as the kappa, is equal to 2 divided to the 27. Well, that's going to be the curvature of this curve at this point t is equal to the square root of 2. Well, you can see here that you have to do lots of calculations in order to calculate this, and you need to be very careful in your calculations. The question number 10, you have to find a position vector, which is going to be super easy, right? So position vector AB, so the AB position vector is obtained by just subtracting the ending point the starting point from the ending point. It's going to be, the ending point is B, so 1, 1, 1, and the starting point is A, which is 1, 2, 3, and you have to subtract the starting point from the ending point always. So you need to be careful with the signs. So if you subtract that, it's going to be 0, minus 1, and minus 2. Question number 11, you have to find 4a plus 5b. So I'm just going to multiply the 4a, right? 4a plus 5b. It's going to be 4 times the 8i plus 2j plus 5b. It's going to be 3i minus 5j. Then I'm just going to open the brackets and simplify the terms. It's going to be 4i plus 8j plus 15i minus 25j. Then I'm just going to add the terms with the I separately. It's going to be 19i. Then also I'm just going to add the terms with the j separately. It's going to be minus 17j. Well, that's going to be this vector. Question number 12, where we need to find an equation of the plane through the point P with a normal vector n. Well, that's going to be super easy because there is a formula to do that. So it's going to be n times the x, y, and z is equal to the n times the p. This is how you can obtain an equation or the general equation of the plane. Well, let's do this. So it's going to be 3, 2, 1 times as a dot product as the x, y, and z is equal to the 3, 2, 1 times as the dot product is a 1. So there is a dot product, 1, 1, and 1. So on the left hand side, we've got 3x plus 2y plus z is equal to 3 plus 2 plus 1. We have to multiply these two vectors as a dot product, which is going to be equal to the 6. Well, 3x plus 2y plus z is equal to the 3. 6 is going to be the equation of the plane, which is passing through this point P with a normal vector n. The question number 13, we have to find a vector equation of a line which is given through the following parametric equation. Well, so you can do this in two different ways. So one way is easier but difficult to understand the concept, and the second one is easier to understand the concept but you have to do more calculations. Well, let's do the second one when it's easier for us to understand this. So in order to construct the line, you need to know one point on this line. So let's say some point A, and also you need to know the vector, right, on the line. So some vector v on the line. So you can get this v vector by just knowing the 2 points. So it appears if you know 2 points along this line, you can figure out its equation, because this v vector can be obtained by just taking the vector between these 2 points. So essentially what we have done so far, right? So the position vector AB is going to be our vector v, which is parallel to this line, and the point A is going to be the point on the line. And the vector equation of the line is going to be r of t is equal to a plus vt. Okay, so how to find 2 points on the line if you are given the parametric equation? Well, just choose any values for the parameter and find the 2 points. For example, if you just plug in t to be equal to 0 to all of the 3 equations, you're going to get x, y, and z. That's going to be the coordinates of the first point. Well, x is going to be equal to the 2, y is going to be equal to the minus 1, z is going to be equal to the 0. Well, that's going to be the coordinates of the point A. And now I'm just going to put, for example, t to be equal to the 1. So in this case, x is going to be equal to the 6, y is going to be equal to the 0, z is going to be equal to the 1. That's going to be the second point, 6, 0, and 1. And the v is going to be the position vector AB, which can be obtained by just subtracting the starting point from the ending point. It's going to be 6, 0, and 1, minus 2, minus 1, and 0. Well, that's going to be 4, 1, and 1. That's going to be the v vector. Then I'm just going to plug in everything into this formula. So the vector equation of this line is going to be equal to 2 minus 1, 0, plus 4, 1, 1 times to the t. Well, this is how we can get the vector equation of the line if you're given the parametric one. Well, in the question number 14, we have to figure out whether the line is above, below, or on the plane. Well, let me draw the plane and understand what does it mean that the line is above or below the plane. So let's say you're given the plane with some general equation ax plus by plus cz is equal to zt. And also you're given some line. Well, if this line is not parallel to this plane, it's going to intersect with the plane at some point in the space, because the plane is going to from infinity to infinity in the line as well. So they're going to intersect at some point anyway if they are not parallel. Well, we can identify whether the line is above or below only if they are parallel. Well, how we can identify whether the line is parallel to the plane? Well, in order to do this, we need a vector v on the line, and also we need the normal vector to this plane. So these two objects, the plane and the line, are parallel if and only if the normal vector to the plane is orthogonal, perpendicular to this vector v. So how to find n, the normal vector of the plane, from the equation? You just need to copy the coefficients before x and y and z. It's going to be 6, 4, and minus 4. And in order to get the v, we are going to use the equation of the line. If you remember, the equation of the line was r is equal to some point a plus v times the t, right? Some vector is multiplied to the t. So all of the coefficients of the t for the x, y, and z are going to give you the components of the v. Well, there is no t on the x here, so that is why its coefficient is going to be equal to the 0. So here the coefficient before the t is 1, and here the coefficient before the t is 1. So that is why the v vector is going to be 0, 1, 1, 0, 1, 1. So the n vector is going to be equal to 6, 4, and minus 4. And the v vector is going to be equal to the 0, 1, and 1, and we have to multiply them. So the n times the v is going to be 6 times the 0, which is 0, plus 4 times the 4, which is 4, minus 4 times the 1, it's going to be minus 4. Well, that's going to be equal to the 0. It means that they are orthogonal. It means that the line is parallel to the plane. Well, now, in order to understand whether this line is above or below the plane, we just need to find one point on the line and check and substitute this into the equation of the plane. Okay, so let's choose one point on the line. So here, this point, it's going to be 0, 1, and 1. Well, this is a point from the plane, where 0 to t can be a point on the plane, on the line, because if you substitute this into the equation of the line, it fulfills that. I'm just going to substitute this into the equation of the plane. So it's going to be 6 times the 0 plus 4 times the 1 minus 4 times the 1. Well, that's going to be equal to the 0. Well, it means that this point is lying on the plane as well. So this point 0, 1, and 1 is on the plane as well, because it satisfies its equation. It means that since the line is parallel to the plane, and also there is one point which is lying at the same time on both on the line and on the plane, it means that the line is lying on the plane. Well, so the answer to this question is the line is on the plane. Well, in the last equation, we have to find an equation of the tangent line to this curve at the point t is equal to 0. Well, it's going to be like this. So let's say you are given some curve with the vector equation r of t, right? And if you would like to figure out the tangent line, so in question number 15, we have to find the equation of the tangent line to this curve at some point t is equal to 0. Well, again, so if you're given some line, which is given with the vector equation r of t, and if you would like to figure out the tangent line at some point here, at some point t is equal to 0, what you need to know? So you need to know the vector which is in the direction of the tangent line, and this vector is going to be simply r prime of t at this point t0, right? T is equal to 0. And if you know, and that's going to be the v vector. If you remember the equation of a line, r of t is equal to some point a plus vt. So the v, which is a vector on the line, is going to be simply the derivative of this curve at this point. And the a is going to be some point on this curve, and actually you can find this by just substituting the t into this equation. It's going to be the a. Well, let's do this first of all. So the r of 0, it's going to be 0 e in the power of minus 0. So 2 times 0 minus 0, it's going to be 0. It's going to be 0, 1, and 0. Well, that's going to be the coordinates of the a point. It's going to be 0, 1, and 0. So now we have to find a vector which is parallel to this line, the v vector essentially. In order to do this, we have to first of all take the derivative of the r. It's going to be a 1 minus e in the power of minus t, 2 minus 2t. And we have to evaluate this at the t is equal to 0. Well, let's do this together. It's going to be a 1 minus 1, then 2. Well, that's going to be the components of the v vector. Now we just plug in everything into the equation of the line and find this. So the equation of the tangent line is going to be a point with the component 0, 1, and 0, plus the v times the t. It's going to be a 1 minus 1 and 2 times the t. Well, that was the last equation of the exam number 2. I hope that you understand the solutions for all of the problems, and I hope that this is going to be helpful in your further exams. Thank you very much.